Hello boys and girls, Mr. Giamini. I wanted to come to you with the last online video. Well, let's see how long it takes me to make this, but this should be one of the last online videos I'm making for any online assessment for the year. This video is going to cover topic 8, which is all about data analysis and statistics. As I've said in the previous 7 videos, remember, ideally you'd want to take the online assessment, do not submit it, but take the online assessment, have answers, have work for every single problem. I think this assessment has 10 questions, so you should have 10 not pages of work, but work for 10 problems. Now you come back, watch this video, compare your work with my work, compare your answers with my answers, see if I'm wrong anywhere, if I made some mistake, or maybe you find that you made a mistake somewhere, and now is your chance to learn either from my mistake or from your mistake. All right, with that being said, let's begin. First question, now I'm going to move this over slightly. Which is a statistical question that could have been asked to collect data shown on the dot plot? It says we're looking for a statistical question. Now we're going to get multiple answers here, a variety of answers. That's what we get for statistical questions, a variety of answers, not just one answer. And we have the numbers, answers of 0, 1, multiple people said 2, 3, 4, and 5. Oh.
Hey, Catherine, if you're in the building, please come to the office. Thank you.
There we are. Mr. Pelt's making an announcement while I'm making my video. Thank you. For question A, or choice A, how many students are in your school? If you have a school where there's only 5 people in your school, chances are it's not a big school. I don't know what school has 0 kids. I'm going to rule this one out. On what day in July is Independence Day? I would think that everybody would know it's July 4th, but even if you didn't, there's no such day as July 0. How many televisions does your family own? There could be a family without a television. You might have one. You wouldn't have 2. You might have one in the family room, one in the basement. Maybe mom and dad have one. That would make sense. 4 seems a little extreme, but possible. 5. Maybe grandparents live with you. Maybe they have their own TV. Older brother or sister might have one in their room. What is the height of your classroom door? Again, if your classroom door is 0 inches or feet, you're not getting into it. There's no door. Correct answer here would definitely be C. That makes sense with that data right there. Next question. The data set shows the number of hours spent on homework yesterday for 10 students. Choose yes or no for each statement. Well, right now I see we have to find range, median, median, median. I'm having a hard time doing any of that because this data is not in order. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values in this data set. I'm going to put an order from least to greatest. I have a 1. I have, oh, my pen went nuts there. I have a 1. I have 1, 2 2s. 2 and 2. I have 1, 2, 3, 4 3s. That would appear to be my mode right now. I have 2 4s. And I have a 5 as my greatest value in the data set. The range for this data set is 3. Remember, range is we're taking the maximum value, which is 5, and subtracting it from the smallest value. 5 minus 1 would give me 4. That would be a no. The range is not 3. The median and mode are 3. Well, I agree that the mode is 3. Remember mode? Think about mode. M-O. Most often. What value appears most often for the word mode? Most often. That's definitely true for this. I agree. The median, the value in the middle. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data in this data set. Split it in half to get my 1, 2, 3, 4, 5 lower half of data, and 1, 2, 3, 4, 5 upper half of data. The number in the middle of 3 and 3 is 3. So this would be a yes, that is true. The median and mean are 3. Well, I agree that the median is 3. The mean, we'll have to add them all up, divide by 10. Plus, plus, plus. And these values are big enough that I think I can add these without having to do much work. Let me do plus, plus, plus. Well, I have to write them all down. Let's go. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is what? 14. 14 plus 3 is 17. We have 17. And then we have 4, 4, 5. 8 and 5 is 13. 17 plus 13 gives me 30. 30 divided by, I think we said 10 numbers, would give me an answer of 3. So that would be a yes as well. The median is 3 and the mode is 2. We've already stated the mode is 3. It can also not be 2. So this would also be a no. All right, let's move on. The number of apps that 8 students downloaded last year are shown below. 16, 12, 18, 8, 17, 15, 22, 17. Drag the correct word to each box to make the inequalities true. Oh, inequalities. We're talking about greater than, less than, greater equal to, less than equal to. Each term must be used once or not at all. All right, again, I'm going to do the same thing I did last problem. Let's put this data in order from least to greatest. 8's done. We have a 12, a 15, a 16, 2 17s, an 18, and a 22. Let's see, 8's checked off, 12's gone, 15's gone, 16's gone, 17's gone, 17's gone, 18's gone, 22 is gone. All right, let's figure out the range first of all. My range. A lot of work to do for this problem. Persevere through. Range, we're taking 22, the largest value, minus the smallest value, which is 8. Well, 22 minus 10 would be 12. We're taking 2 less away. So wouldn't that be an answer of 14? We have the mode. The value that appears the most in this situation would be 17. The median, the value in the middle data set, 1, 2, 3, 4, 5, 6, 7, 8. We're going to take the upper half, lower half. The upper half, halfway between there would be 16 and a half. So the median for this data set is 16 and a half. Oh, the mean, of course, I got to add all this up. 8 and 12 is 20. 15 and 16 is 31. 17 and 17 is 34. 18 and 22 is 40. Let's add all that up. That gives us 5. 6, 10, 12. That's 125 divided by 10. I'm dividing by 10. It kicks the decimal over 1. That gives me 12 and a half. So the mean is equal to 12 and a half. Now let's take a look here. It says the mean is greater than something. Well, unless I did something wrong, I have the mean being greater than nothing. Let's go back and see what I did wrong. Do I have all the values? 22 minus 18. Let's just double check my 22 minus 8. That becomes the 12 like we said. That's a 1. 12 minus 8 is 4. That's 1. That's 14. Check with that. My mode is 17. Check with that. The median I said was 16 and a half. 16 and a half. Let's take a look here. 8, 12, 15, 16, 17, 17, 18, 22. In between is 16 and a half. Median 16 and a half. The mean, did I add them up wrong? That's 20. That's 31. That's 34. And that is 40. 5. Let's see here. Maybe I added this wrong. 6, 7, 8, 9, 10, 11, 12. Okay, 125 divided by 10. Well, let's just double check. Maybe I did something wrong. This would give me 1. That's 10. That's 2. Bring down the 5. That is 2. That is 20. That's 5. Bring down the 0. That's 5. I have 12 and a half. According to my math, the mean is not greater than anything in this data set. What am I doing wrong? I have to be doing something wrong. I'm dividing by 10. How many numbers in our data set? 8. 12 and a half. Oops, 125. 125. 125, let's try this, Mr. Me. 125 divided by 8. That gives me 1. That's 8. Put a 0 there. Subtract, that's 4. Annex down to 5. 8 goes into 45, I believe, 5 times. That gives me what? 40. That's a 5. Bring down the 0. Put a decimal point there. 8 goes into 50. What is that? 6 times, which gives me 48. Which 2 left over, which gives me 2, which is 16, which is 4 left over. Bring down the 0. That's 5. All right, there we go. Isn't it great how when you make a mistake and you get frustrated like that, if you just stop, take a look, reread. I said 8 students. I was counting 10 for some reason. Don't know why I was doing that. Now, 15 and 625. Oh, wait. That's greater than the range. And it looks like the median is smaller than the only number that's smaller than is the mode. There we go. All right. Love it. Excellent. Worked through my struggles. Realized that this was foolish. I used the wrong divisor. It should have been 8 all the time. All my other math was great. Awesome. Moving on. Let's take a look here. It says, the data for the 10-year period in inches. I got to do 10 years, and I have to find what's the MAD. First thing I have to do, I don't need to put these numbers in order from least to greatest. I'm doing MAD. I have 23 here. I'll do 27 underneath. 19, 20, 27, 18, 26, 22, 28, and finally 30. Oh boy, it's a lot of numbers to add up. 8 and 2 is 10. 10 plus 6 is 16. 16 plus 8 is 24. 24 plus 7 is 31. 31 plus 9 is 40, right? Wasn't that 40? Double check, see? Gotta double check this. 8 and 2 is 10. 10 plus 6 is 16. 16 plus 8 is 24. 24 plus 7 is 31. 31 plus 9 is 40. Plus 10 here gives me 50, so that's a 0 here. I put a 5 up top. 2, 4, 5, 10, 12, 14, 16. Oh, wait a minute, what did I do here? Always double checking here. Let's just go to the 2s. 2, 4, 6, 8, 10, 12, 14. Got all the evens. 14, 17, 18, 19. Plus 5 is 24. I go 240 divided by, there's 10 values in a data set, that equals 24. I now take this mean and subtract it from all of these, but I'm really not subtracting. Remember, I'm finding the distance. I'm really finding the distance between the mean and every value in the data set. I'm kind of trying to figure out, well, what's the variability of this data? Is it there's a lot of variability, meaning there's a variety of numbers? Are they tightly clustered? The variability is, if the MAD is close or a small number, that means this data is pretty tightly clustered. Now let's go ahead and find our distances between here. Distance between 24 and 23 is 1. Between 27 and 24, 3. Between 19 and 24, 5. Between 20 and 24, 4. 27 and 24, 3. 18 and 24, 6. 26 and 24, 2. 22 and 24, 2. 28 and 24, 4. And 30 and 24, 6. Now, I need to add all these together. Let's see if I can do a better job adding these. 6 and 4 is 10. 12, 14, 20, 27, 30. I get 36. I now divide that by, I added 10 differences. That gives me the MAD is 3 and 6/10 inches. There we go. Wow, this would be the average. Did that take me a while? Absolutely. We'll have to look at the timer, see how long it took me exactly. But again, the goal here is to get them right. I have a lot of numbers, a lot of computations, calculations going on. I am going to need to take my time to get these right. Let's go take a look at the next question. The histogram shows the number of points scored by a basketball team for one season. Points scored in one season. I like that it has a title. We have number of games with a frequency. We have the intervals down here. Points scored. I can tell between 69 and 76, 3 games. 77 and 84, 6 games, 85 and 92, 8 games, and 93 and 101. According to the histogram, in how many games did the team score between 77 and 92? Now, if I look, there's no interval, 77 and 92. That means I'm including 77 and 84 and 85 and 92. Here we had 6, here we had 8. Let's add those together. 8 and 6 gives me a total of 14 games. All right, moving along. Drag the numbers to make the statements correct for this box plot. Ooh, box plot. I like box plots. We have lower extreme. We have upper extreme. We have quartile 1. We have quartile 2. We have quartile 3. The first quartile looks to be 6. The third quartile looks to be 14. The IQR is this quartile 3 minus quartile 1. That is this middle 50% of the data. 50% of the data falls in between quartile 1 and quartile 3. The distance between these two numbers, quartile 3 is what? 14 minus, we had 6. That would give an IQR of 8. IQR is great when we're using median, when we're looking at a large data set, when we have an outlier or multiple outliers. Moving along. 8 students are selling wrapping paper for a Cheer Squad fundraiser. In the first week, they made the following numbers of sales. What is the MAD of their sales? This is another MAD question. This is starting to make me mad. Now, here's my thought as I write these numbers out. If they have 2 MAD questions on the online video, or the online assessment, my guess is that they'll have 2 MAD questions on your post-test, the paper and pencil version. Something to think about. Let's add these. 6 and 2 is 8. 8 and 7 is 15, correct? 15 plus 9, 24. 24 plus 3 and 3 is 6. 24 plus 6 gives me 30. Let's put a 0 here. We'll put a 3 up top. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to double check that one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, there it is. Oh, I'm using Christmas colors here. We're going to take that and divide it by how many values in a data set? 8 students. Divide it by 8. I'll go over here, 120. Divided by 8. This will give me the average, the mean. That goes in once. That's 8. I subtract. That's 4. Bring down to 0. 8 times what factor gives me 40? 8 times 5, 15. Now, we're going to take that 15 and subtract it. Find the distance between the number in the data set, or the value in the data set, and the absolute, or the mean. We're going to find the absolute deviation. How far each value deviates from the mean. So now we're finding the absolute deviation, not the mean absolute deviation, just the absolute deviation, the distance between the two. This would give me 5 apart, 3 apart, 1 apart, 2 apart, 6 apart, 5 apart, 2 apart, and 8 apart. Let's add all those deviations, all those absolute deviations together. 5 and 3 is 8, 9, 11, 17, 23, 25, 33. Am I right in saying that? That seems odd, doesn't it? Let's take a look again. 8 here. Now we have 9, right? Now we had 2 more, we have 11. We had 6 more, we have 17. We had 5 more, that's what, 23. We have 2 more, that's 25. We have 8 more, that's 33. Still not convinced that I have this right, but let's take a look. We're going to take 33 now. 33, and now we're going to divide that by 8. Let's take a look. 33, because there's 8 data set, 8 data values, divided by 8. That gives me 4. That gives me 32. That's 1. Annex down to 0. That gives me a what? That's a 1. I'm looking here. I don't have that answer. What did I do wrong? Could I have done something wrong? Well, I've done a couple things already. Let's take a look. I'm going to go back to my deviations. My absolute deviations. 5, yes. 3, yes. 1, yes. 2, yes. 6, yes. 5, yes. 2, yes. 8, yes. Okay, I agree with all that. Did I add incorrectly? Let's take a look again. Let's take a look again. 5 and 3 is 8. 8 plus 2 is 10. 6, 5, 2 is 6 and 5 is 11. 11 plus 2 is 13. 8 plus 1 is 9. Look at that. I got 32. Yes. Now I see something. 32 divided by 8 will give me 4. My mean absolute deviation is 4. Again, boys and girls, I'm going to keep working. If I'm not confident, I'm going to go back and look at it. This is my test. I want to make sure I can earn every possible point. Am I making mistakes? Yeah. Am I making careless mistakes? Absolutely. And that's okay, as long as I go back and fix them. All right? I can make a mistake. That's going to happen. But I guess I am making a careless mistake, but the good thing is I'm catching them because I'm thinking about that. The answer doesn't make sense, especially on multiple choice. I did something wrong. Moving on. Grace made a dot plot showing the distance she ran each day for 2 weeks. She says that she usually runs 7 miles each day because this is the distance that occurs most often. Do you agree with Grace? Use the drop-down menu, explain. Let's take a look. We have one. She did 1 mile once, 2 miles 3 times, 3 miles 3 times, 4 miles 3 times, and then she didn't do anything for 5, didn't do anything for 6, and then did 7. Well, the mode is 7, but that's not what she typically does. So this is not typical of Grace. Did she do that often? Yes, 4 times. But 4 out of, let's see, 4, how many times did she run here? 9, 10, she ran 14 times. 4 out of 14 is not even 50%. That's not even 50% of the time. That doesn't mean Grace is doing that often. The median, well, let's take a look at the median. We have 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 7, 7, 7, 7. The median, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 is an even number. Let's cut that in half. Let's go 7. There's 1, 2, 3, 4, 5, 6, 7 here. Let's go 7 here. Now the median is that number in the middle. That's going to be 3.5. This is typical. This is a typical data for the data set. If I take a look, we got some tight cluster here, we got tight cluster here, we got a little bit of a gap there. The median would be a good one to use. So this is a good number to use. The mean, which is, okay, here we go with mean. 1 plus 2 is 3. Let's slow down here. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 3 is 10. 10 plus 3 and 3 is 16. Okay, this side equals 16. Let's lower half of 16. 9 plus 6 is 15 plus 1 is 17. Let's go. 3 fours is 12 plus 1, 2, 3, 4. 7s is 28. 20, that gives me plus 40. That gives me 56. All right, let me just make that a little nicer there. 56. We divide that by 14. 56 divided by 14 is equal to 4. So the mean, which is 4. Now here we get a little tricky. We have this gap here. We have this gap. We have a nice cluster here. We have a gap here. Then we have a cluster here. Let's talk about this. When I have those multiple clusters, the mean is not good to use because those 4 times that she ran 7 miles, that's pulling the mean up. We're taking those into account. But really, again, that's not typical for Grace. The mean should be that number that's in the center. Is it a half off? Yes. Does that seem like a lot? Not really. But we're talking about a half mile. Well, running a half mile could be significant. That means the mean is not a typical distance for this data set. So Grace her reasoning is not correct. All right. Let's take a look at the next one. Ronika recorded the number of games that the school softball team won each year for the past 7 years. 31, 34, 24, 32, 22, 34, 28, 38. What is the third quartile? Last 7 years. Let's take a look. I got to put these in order if I'm doing quartiles. 22, 24, 28, 31, 32, 34, and 38. 7 years, or seven seasons, correct? 1, 2, 3, 4, 5, 6, and 7. We want to cut this. There's my first quartile. There's my Q2, my median of the entire data set. Here's my upper half. We're looking for, what are we looking for again? Isn't it quartile 3? Here's quartile 1. Quartile 3 would be right here. That is 34. 34 games. All right, moving on. Last question. Oh boy, a lot of data here. Mrs. Jameson kept track of the amount of money that her family spent when they ate out at restaurants over several months. Choose true or false for each statement about the data. The mean represents the center of the data accurately because there are no outliers. So let's take a look. 56, 24, 54, 44, 54, 44, 54, 150. Wow, that really sounds big. 25, 40, 48, 60, 40, and 50. I'm going to say that is no. False. That is a huge, that's almost nearly 3 times as much as the next largest. The next is 60, nearly 3 times more. I'm going to say no, it's a false outlier. Mode. The mode represents the center of data accurately because the most common data is at the center. No, that's not always true. I'm going to go false with that. The mode is not always the center of the data. The median. I'm going to say yes. The reason being, I'm sorry, true. I put an F there. That's going to be a true. The reason being, it eliminates this outlier. It almost eliminates this 25 too, which appears to be pretty low for that family. The range represents the range does not represent center. It represents what? It represents validity, spread. Now, find the IQR. IQR meaning I have to now break this up into quartiles. We have 25. 25. Our next lowest is 2 40s. We then have, let's cross out these 40s. We then have 1, 2 44s. We then have a 48. We then have 54s. 1, 2, 3 54s. 54, 54, 54. We have a 56, a 6. Oh, did I skip that? I skipped the 50, didn't I? Yeah, I sure did. Let me do this. Let me shrink my eraser down a little bit. We'll just sub this with a 0. We'll add that 54 there on the bottom. So it's 50, 54, 54, 54. I said we had a 56. We had a 60. And then we had that, what is it, 150. Let's double check if I had all the data values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, split it in half. So let's go 7s because half 14 is 7. 1, 2, 3, 4, 5, 6, 7 here. And 7. We're looking for the IQR. We have 40 here. We have 54 here. The IQR would be 14. And that would be a good, that's my IQR. Again, if I talk about the mode being the center, look, it's 54 here. The middle would be 49 for doing the median. We're not really close. We're $5 off. Again, the mode is better to just show how much a most frequent number. It's not the true center for this data set. Hope this helps you out in your test preparation. As you can see, I made some mistakes. I wanted to show you how I could fight through those mistakes, how I can learn from them. You take my time. Sometimes making a video too, it puts you under pressure. I'm making excuses, aren't I? I messed up. Find my mistakes, learn from them. Take care. Good luck in your test preparation.